Last time then we were looking at how we can use the features of .NET to put together a syntax tree representing a .NET program but in a hierarchical structure within another program. And then we saw how, having done that, we could use that to generate some actual C# code which could then be put into a project and compiled. But what I said I was going to lead on to was the idea that we can actually do that compilation process as part of the program that generates the code anyway. It's not just about generating the code. So let's just recap what we had. We had here this really rather complicated bit of code that puts together our structure to create, in this case, a Hello World program. And then that gave us back this syntax tree. And then we simply used this bit of code here to write out that as C# in a structured way. So if we run that up, we can see that is the code that was being put together. And what we'd like to do now is take that and actually compile it down to intermediate language. Now, it's important to recognize that these are two completely separate steps in the process, and they do not have to depend on one another. If I wanted to programmatically compile some C#, I don't have to go to the effort of all this very complicated syntax for putting it together. I could do it rather more simply. I could have just said tree equals, and then we could say C# syntax tree dot parse text, and then in here I could have started putting things like using system and then class program, and just wherever I want to get the code from, could have read it into a file. And then that parse text would basically deconstruct all that code and turn it into the tree that we've got here. So you can create the trees either directly or just by reading in some C# code and parsing it. But we'll stick with the one that I created there. And then you can see I've put together this empty function called build assembly that's going to do the work for us. And we're going to pass into that a syntax tree and also the name of the assembly that we want to generate. So what we're going to need to do, firstly, whenever you do a build of a C# project, as well as your own code, it's going to be dependent on some other assemblies. And we can see those in Visual Studio if we just look at dependencies and then look at frameworks. We can see in this case it's just dependent on the basic core application, and then in this case also it's dependent on the code analysis stuff that is what we're using here. So in a more complicated program there are going to be further dependencies, but when we build it we've got to specify what those are. So what we do is we can say we're going to have a list of things called metadata references, and we'll call these references, and say that equals a new list of all that. And then we've got to add into that the ones that we need. And it's going to be quite a bit of thought to know what you're going to need based on the program that you've written. But what I happen to know we need here, we're going to need a metadata reference that we can do. We create from file is one way to do it. And then we can say assembly.load, and then simply have the name of the assembly. So I know I'm going to need system.private.corelib. That's where the fundamentals of .NET Core are stored. And then I just say .location on that. And so that opens up the assembly in my program, gets the location, and we're going to pass that into the C# compiler for the other program we're writing. And then we're going to need a couple more of those. We're going to need system.runtime, and we're going to need system.console because we're using console to do the write line in that one. So that's what we have there for our references. And I'd say that's going to get bigger if we have a more complicated program. Then we're going to need to actually put together our compilation. So we have this thing called a C# compilation. And then we say C# compilation.create. So it has its own factory in there. And then we're going to pass in our assembly name that we've already got specified there. We're going to pass in our syntax tree. Now, in fact, you can compile multiple syntax trees, multiple compilation units within a single one of these compilations. So this actually takes a collection of them. So we're going to have to say new and then put syntax tree as the one and only one. But if you had more, you could put them in there. Then we're going to pass in our references that we've just created. And then finally, we've got some options. So we have a new C# compilation options. And the one I'm going to go for is I'm going to set the output kind to being a console application, because that's what we're trying to write for our hello world. So that's specified the compilation rules that we want. What I'm then going to do is just make a separate folder to put this stuff in. Obviously, it's up to you to decide where you want it, but let's just have a directory dot create directory, and we'll just call this output. And then let's create a file stream to write it to. So I'll have using file stream equals new file stream, and then I'm going to say path dot combine, and so the output that we just created along with the name of the assembly that was passed in. So that's what we have in there. And then I'm also going to put on here a file mode create, just so that it creates a new one every time rather than appending, which just would be a ridiculous thing to do. And so that's set up our file stream. And then it's as simple as this. We can simply say this emit result, and then call that result equals compilation dot emit. So send the compilation results to the string. And so that will attempt to compile it. If the compilation fails, it will give us back errors. Otherwise, it will have generated the DLL. And we can look at the errors. We can just do a for each of var diagnostic, let's call it, in result dot diagnostics. And then we could just do something like console write line and then diagnostic dot ID gives us the code number for it, and then diagnostic dot get message, and that will give us the text of it. So that's all of that code working. Let's just call that function then. So we're going to, after we've printed out the text, we'll call build assembly, and remember that takes in the tree and then also takes in the assembly name. So I'm going to call this my hello world, and then I'm going to do something very odd that I'll explain in a moment. I'm going to call that a DLL rather than calling it an executable, an exe, even though we've said the output is going to be a console application. We'll see why in a moment. What I'll actually do before I do this properly is we've printed out that diagnostic information. Let's actually introduce a deliberate error. So let's just call a method on console that doesn't exist just to make sure that we're getting those errors. So now that should be listed out there. So we'll run that up, and we can see we get the printout that we just had before, and then console does not contain a definition for WYBL. So exactly the sort of thing you'd see in the error list in Visual Studio if you'd compile this in the ordinary way. However, let's fix that. So we'll change that back to write line, which should work correctly. And now let's run it again. And we should see now that it finishes off no errors at all. So let's actually see what's being generated there. And so what we'll do is bring up a file explorer. And then if we drill down, we'll go down to bin, debug, net5, and we can see that there it's got our folder called output. And there we've got the My Hello World. It's not very big, but that's what we've got. Now let me explain this thing about that being a DLL, because if you look at the program that was actually generated by the Visual Studio compiler, you can see it's generated a couple of things. It's generated a DLL and also an executable. And in fact, the executable isn't really part of .NET. What you have to remember is with .NET Core, it runs on multiple platforms, not just Windows. And so that DLL will run on any platform that's got .NET Core installed. But it needs a kind of bootstrap just to load it in. And that on Windows is what CodeAnalysis.exe is. And if I just show an example of that, if you just go back to the code and for now get rid of that build assembly. If I now go into here and bring up a command prompt, and if I obviously type the name of the executable, CodeAnalysis.exe, then we see the output, which is the text of that. But if we were running this on a non-Windows platform, it would be very simple. We just use the .NET command line, and then we say code analysis, not .exe, but .dll. So we're getting .NET to run the DLL, and it will give us exactly the same results. So all that's happening in that executable program that you get generated by Visual Studio in lots of circumstances like this, it is just wrapping up basically that .NET code analysis.dll. So that's why if we then take a look in our output that we've got this my hello world.dll. And if we again bring up a command prompt, then it should simply be a case of saying .NET my hello world.dll. But it's not. We get this error, which is a horrible one when you see it, but it's actually pretty simple to fix. If we again go back up, we can see that every .NET application has to have this runtime config.json. If you take a look inside it, it's not telling us very much, just the basic information. You might want to change that, but that's what we have. But what that means is if we just take that, go into output and paste it, and then simply rename it to my hello world, then that provides the information to allow us to run that DLL. And then in here, if we now do our .NET myhelloworld.dll, it says hello world. That is probably the most complex hello world application I've ever written, but it shows us a huge number of concepts that once we've got them, we can then expand that into producing dynamically from our own code programs to do whatever we like. So we've seen how we generate the syntax tree with all those fiddly components. We can then either use that to generate just text, just some C# code, or we can use it, as we saw here, to build the intermediate language to generate the DLL and do that all dynamically. Sort of situations where that might be useful. Well, good few years ago now, actually, before this sort of thing came along, before I was even using .NET, I was working on a C++ project for an actuarial company. So an actuarial company where they had to do very complicated mathematical calculations as to basically what the expected outcome for all sorts of insurance policies, life insurance, that sort of thing, would be in decades' time. And so actuaries are specialist mathematicians who understand how to do these calculations, but aren't programmers. They don't understand C++. So what we did was we developed a relatively simple formula language that the actuaries could write their code in. And then we translated that into C++, compiled the C++, and therefore could run very efficiently these formulas that the actuaries had written. And that was quite a complicated thing to do in C++. If we'd had this in C#, it would have been much simpler because we could have simply taken the code from these formulas. We would have then put together something like we've got here, dynamically, a program in C# based on that code, compiled it, and having it run very quickly. Now, we'll actually look at something a bit like that next time, where I'll put this together to make a slightly more complicated, reasonably realistic program, where we can actually use this to dynamically generate DLLs that will then plug back into an existing program to add functionality in a dynamic way. So I hope you enjoyed that. If you did, do click the like button, do subscribe, and I'll see you next time for that slightly more realistic example.